Yeah, guys, and I want to introduce our next speaker, our next fellow developer. His name is Paya Atai, and I guess without a further ado, since I stole a couple of minutes of his presentations of his talk, I'll just pass the microphone straight ahead to you, Paya, and I won't occupy any more space. So back to you.
No problem. No problem. All right, so I'll get right into it, and let's start today. It's very great conference so far, and it's a beautiful day here in New Zealand. So let me just share my screen with you fellows, and let's get into it. All right, this should be fine now. Alrighty, so the topic of today is a little bit different from other presentations in a sense that it does not aim to describe a certain technology or a niche or a way of animating elements on the mobile application or certain library. What I'm planning to do for the purposes of this speak is to sort of talk about the high-level, bigger picture of cross-platform development tools. What I've done is that I went and researched all these development tools, added my personal experience into it, and added other fellow senior devs experience into this as well, which gave me an overall good view, which I'm gonna share with you very shortly. Before getting any further, let me introduce myself. My name is Puya. I'm a front-end tech lead at a company called EasyWet. Excuse me. What we do at EasyWet is that we have a cloud-based veterinary application, and we sort of provide software for hospitals, vets, and lots of clinics as well. All right, let's get into it. For the purposes of this presentation, I will be your guide as we explore 7 of the most popular cross-platform technologies. I think I messed up my slides a little bit. Just a second, sorry. Things happening at the right time. Okay, I have 2 instances. That's why. So yeah, I'm going to repeat myself. For the purposes of this presentation, I will be your guide as we explore 7 of the most popular cross-platform frameworks. Let us suppose you are a technical lead, or you are just a developer, or you are an intermediate, junior, just a business owner, or a marketer. You would like to come up with an app, and you would like to assess your resources available. And based on that, you're going to say, all right, we're going to pick this technology or that technology. This presentation is a good thing for you. This is also very good for devs because it will give you a little bit of taste of all these frameworks. And I will also discuss the architecture, the underlying architecture. And I'll also talk about a history and what, as a community, we've been through, how we failed, and where are we right now. So the cross-platform frameworks that I've chosen are Cordova, Ionic, React Native, of course, Titanium, Xamarin, NativeScript, and Flutter. These are like the most commonly used these days. I mean, some of them are not, they're really old, but yeah. Looking at the frameworks from the project lead perspective, we will investigate the technology used by each framework and discuss pros and cons, and it is sort of a little taste of little bit of every single one of them. Just as I mentioned, we know that there are lots of cross-platform tools out there, but one thing we have not paid a clear attention to is that how these cross-platform tools are categorized. Developing apps for major smartphone platforms, you need to be proficient in several object-oriented programming languages. You need to pick up IDEs. For example, you need to know Java or Kotlin, Swift or C, and then get yourself around Apple Xcode or Android Studio and lots of libraries that you like to work with. And, it's kind of a universe of its own. There is absolutely no time for you as a busy dev working 8 hours a day to come home and figure out all these things by yourself. So cross-platform development seeks to alleviate the pain of learning multiple languages and tools to support multiple platforms. In general, there are based on my research, there are two types of cross-platform apps. Those that use web technologies and those that are translated to native apps. Those that are using the web technologies are called the hybrid cross-platform technologies. And those that directly translate into native apps are called native cross-platform technologies. Hybrid cross-platform technologies make use of the browser component of the platform, to be specific, the WebView component. Example of such technologies are Cordova and Ionic, which we'll speak about shortly. Native cross-platform technologies, on the other hand, tend to automatically translate your code into the native code by a tool, usually called the bridge. And examples of such technologies can be Titanium, Xamarin, NativeScript, React Native, and Flutter, of course. To get a little bit deeper about how the first category of our cross-platform technology work, we'll first discuss the hybrid apps. Cross-platform hybrid apps are mobile apps that are derived from web apps built using HTML, CSS, and JavaScript. In general, the web API is converted by a hybrid app framework. So you write your HTML, CSS, and JS. And there is a hybrid web framework that turns your HTML, CSS, and JavaScript into the native app. This process happens through the whole hybrid web framework. The web framework is responsible for building the native app and packaging the web app properly so that it can run on a targeted device. The result of the conversion process is an app that can be listed in the App Store. Every modern platform includes a built-in browser component, generally called the WebView. So all the mobiles you're running, all the modern ones, they all have a component called WebView. And that's what the cross-platform hybrid technologies are targeting, to turn those web technologies into a hybrid application. So that's, in a nutshell, how cross-platform hybrid apps work. Now let's talk about the underlying architecture. If we take a closer look at the architecture of a hybrid app is essentially a web page where all the assets of the web apps are stored on the device. The web app can include anything that can be loaded into a mobile browser, and this is loaded by the operating system into the WebView. That when I say this is loaded by the operating system, I mean in a specific the HTML rendering engine. First, because the WebView component is a native component, and this sort of HTML rendering engine WebView exists on all the platforms, it has access to low-level operating system services like sensors and graphic engines as well. And it can also have access to very low-level things like getting and processing user input as well. But going this way, this is what we usually see. But this is not the end of it. Like, if the underlying architecture of hybrid apps would only go for this approach, it would be limited to many things. So as a smart solution to this, when that rendering engine cannot support whatever that app needs, in a nutshell, when the WebView component falls short of accessing native device capabilities, hybrid frameworks usually provide plugins that provide access from your app loaded in the WebView to native device capabilities. So these plugins are kind of a little bridge between the rendering engine and the mobile OS native capabilities. I personally perceive hybrid apps the same way I perceive a Python. I think that's a good analogy. When creating a Python application, You write your code in Python, and then you send your code into a Python compiler, and the result is a bytecode that is suitable for execution in Python's virtual machine, or in short, PVM. And PVMs exist for many platforms where your Python code can run and application can be installed. So this is very analogous. That this is the same process that happens for the Java and PHP as well, where you will have one layer of abstraction before you get into the machine code. So that was the hybrid apps. And now let's talk about cross-platform native apps, which is very interesting. If you look at a history of cross-platform development, we started with hybrid apps. We started with picking up HTML, CSS, and JavaScript. And after a while, we realized that's not very smart. It's not going to give us the performance we're looking for. Performance is always the key factor, number one factor. Doesn't matter what you develop. Is it a mobile application, or is it a website, or whatever else there is? Cross-platform native apps came as a solution. And these apps are written in programming languages that aren't actually native to the mobile operating system. So the native app framework is responsible for compiling and translating the code written into the apps and to run natively for each supported platform. Yes, that's a trivial explanation of it. But when we look a little bit deeper into it, we'll see that there are two emerging patterns of cross-platform native apps. One of them is so what I realized is that the first, so I created two types. The first type was the first type of cross-platform native apps were the ones that use business logic for each platform. And sorry, I'm reading things wrongly. The first type of cross-platform native apps are the ones that actually utilize the shared code between business logic and the UI. And the second type are the ones that have different UI kind of handling module and a different business logic handling module. A very good example of it is React Native, where you will have React Fiber reconciliation algorithm creating the Fiber nodes for you. And once that's ready, it will pass it to a renderer. And that renderer could be the web renderer, or it could be the mobile renderer. In that way, it's very smart. Or if you look at Flutter, we look at the widget tree. So to be specific, I think the equivalent of a widget in Flutter is a component in React Native Word. And the Flutter creates these widget trees and pass it down to a UI module, which will handle the rendering of that. So business logic and UI is separated. And that's the second type. The first type, both of them are just like in one process. So there's no separation of each. Now I want to create another analogy. If creating a hybrid cross-platform apps is similar to Python apps, just like I have explained, creating native cross-platform apps closely mirrors creation of a C or C++ application. Mostly platform-independent source code files for C and C++ apps are sent to a platform-specific compiler. So you write C and C++, it will go to the compiler, and that creates a platform-specific object files, and platform-specific object files are then combined with platform-dependent runtime libraries, and linkers, and the result is the executable code for the target platform. This is the reality of many applications that you run on your operating system. In the same way, in cross-platform native apps, you've got the compilers or the bridges that will create these object files, which will be linked and will at the end give you the execution. So yeah, so far we've learned there are two big categories of cross-platform development, hybrid and native. Native has two subcategories, the ones that sort of segregate the UI and the business logic and those that don't. Now let's talk about our oldest friend, which is Cordova, Apache Cordova. So we start with cross-platform technologies first, and cross-platform hybrid technologies first. And Cordova is not the oldest, is one of the oldest technologies that it exists. At its heart, Cordova is really a build tool. You can give it an input, which is a web application, and it produces native apps as output. It supports an interesting amount of operating systems, and that includes some very, very rare operating systems, such as what was the name for Amazon? Amazon OS or something, if I'm not mistaken. Cordova has a lot of plugins as well. Those plugins are robust and extensive. If you're an existing web developer who wants to convert to a mobile app, Cordova is hard to overlook. You can use your existing code to offer your app to all existing platforms supported by Cordova. Cordova has been initially released in 2009, and it has been, and in fact, Cordova has been around for so long that it has derivatives, like, for example, Ionic, which we'll talk about next, is based on Cordova. And for example, PhoneGap is kind of Adobe's derivative of Cordova. Now let's talk about the advantages and disadvantages of Cordova. As with any hybrid cross-platform cross-platform technology, those created with Cordova can suffer from performance issues. Running code inside a web browser, meaning the code is interpreted by the browser rather than compiled and executed natively, which means you will have one layer of abstraction. Every time you have one extra layer of abstraction, you lose a little bit of performance. And that's something you would like to avoid as a developer, because you want things fast, you want to keep people happy. I mean, I'm sure you can provide slick interfaces and animations, but still, it wouldn't be as fast as how you would run it on native. Another problem with Cordova is the tools can be a problem as well. Although it can be really nice to choose your tools for development, almost certainly all the tools you use for Cordova aren't optimized for mobile development. Instead, they're optimized for web development, which is a little bit annoying sometimes because it doesn't address the problems that you're looking for to address. Cordova tries to minimize this via the conversion process, but apps created solely in Cordova won't be able to take advantage of all those new features provided in platform-specific tools. So, yeah, there's always something missing. And lastly, of course, whereas Cordova can be a good option for simple application, the development may be a little bit of a problem because debugging is not as good, and you may find a little bit of hard time debugging Cordova applications for example, an iOS side of your mobile application. If something goes wrong on one specific platform and you want to go back to it and fix it, you're gonna have a hard time a little bit to make it kind of in balance with the, for example, the Android side, or to make it in balance with the iOS side if one of them doesn't look the same or doesn't behave the same. So another problem with native applications is that there's always a gap between what features the native platform is offering and where the native, where the hybrid cross-platform framework is standing. So these people have to catch up with the native platforms, right? They have to come and catch after all those native platforms and see what they've done new. So they will come and write better codes, better frameworks, which will convert your HTML, CSS, and JavaScript into more accurate native codes. And so there will always be a little window between the platform upgrades. And with Cordova, you really don't know if that's going to happen timely or not. You really have no insurance at all that Cordova will even exist in the future. And so as you know, Google and Apple are investing like colossally in improving their platforms and all those sort of things. Yeah, and in a nutshell, Cordova is most probably not the option you want to go for. Now, after that comes the Ionic. So let's say it's 2013 now. It's roughly 4 years after Cordova. And we want something smarter, something better. We want to address some of the issues that I told you about development of Cordova. And now we have Ionic. Ionic is built on top of Cordova. It's basically the mixture of Cordova and AngularJS. When I say AngularJS, it means Angular's version 1 and not anything more than version 1. At the time, it was a very hot framework. Ionic was initially released in 2013. Ionic was built on Cordova and Angular. So in a nutshell, it excels where Cordova excels. It's pretty much based on the same technology, but it has some improvement, which I'm going to talk about. Ionic provides access to starter templates and native plugins beyond those offered by Cordova. And that's a very positive thing if you develop with Ionic. Ionic used to be a very hot thing when it came out, and I had a touch of it as well. It also provides app themes, and it also provides an extensive collection of pre-built components that you can make use of in your apps. At a time, that was a very good thing. It would make you it will make you develop things very quickly. Unless you have a very specific needs, you won't have to roll your own components, and pretty much Ionic got your back and got components ready for you. Ionic also, what they've done was also cool because they included the app available on Apple App and Apple App Store, and Google Play Store to make developing Ionic easier. They had like a dev app, which made it easier to test apps directly on devices, and Ionic View for live app testing, and that was also another cool application. They also, what they've done is that they took Cordova's command line and they enhanced it by including more commands such as start, save, lap switch, upload, resource, all that jazz. So they've basically made it much easier, much better developer experience. I would say Ionic was a solution to all the development problems that Cordova had, if I wanted to give you the shortest explanation of what Ionic is. But there were other cool things that I remember. For example, Ionic provided Pro Tools, such as an IDE. The IDE was called the Creator. Another tool that I remember is called Package. Package was a kind of a cloud-based build tool, sort of analogous to PhoneGap build. So you could just build your application very easily, and it was on the cloud. And kind of like how building is very common these days for static sites and even non-static sites and everything. Ionic had it at the time. So I would say at a time, it was a pretty cool technology. Remote app testing via the Ionic View app was also one of the things that I really liked, and that's exactly one of the apps that I mentioned. So it existed; you could just get it and just debug your application and do a live view. The disadvantages of Ionic is pretty much like Cordova. I don't want to repeat myself, but of course, Ionic is a hybrid app framework built on top of Cordova, so it suffers from many of the shortcomings that all hybrid frameworks suffer from. They're slow, tools are web-based. Between the platform features and the framework, there is a window. Debugging is still the pain. Doesn't go away. I mean, like Ionic tried to alleviate the problem, but it's in the heart of it. Like, it's very fundamental, and it is still not there. Native tools are better than Ionic tools, like Cordova. Sorry, I think I'm misreading things. I've written here native tools. Okay, anyways, doesn't matter. I've got it mixed up. One other thing that I didn't like about Ionic was that aside all the other problems that hybrid cross-platform frameworks had. One thing that I didn't like was the fact that Ionic version 1, 2, and 3 were not compatible. So if you wanted to go from Ionic version 1 to 2, you would have a hard time. You want to go to 2 to 3, you would still have a hard time. So definitely not an option, really. The reason I'm explaining all these things for you guys is that you'll know that here how painful things were before the times of Flutter, React Native, and all these cool technologies. And yeah, so after Ionic, we realized this is not a good way. We can do things better, and we don't have to use the WebView component. How about we write a code that interprets and compiles from one programming language to each platform, which calls the bridging process, or there are different terminologies for it as well. And that was the rise of the native cross-platform technologies. As you all know, React Native is a native cross-platform tool based on Facebook's popular React JavaScript library, React. React Native was invented basically because engineers at Facebook weren't happy with the performance of their hybrid mobile app. So Facebook itself went the hybrid way before coming to native. React Native apps are compiled with a CLI, and React Native outputs native apps, pretty much trivial. The way it works is that, as I explained to you, you will have, this is definitely in the second subcategory of native cross-platform frameworks, where you will have the business logic and the UI renderer separated. So in the React world, which is a technology that I've used the most, you will have an algorithm called Fiber, which is the reconciliation algorithm, which will create these knots, fibers, and once that fibers are in the shape that we want to commit and we want to render, then we'll pass it to the commit phase, and the renderer will pick it up and then make the magic happen. Honestly, React is getting more interesting and more interesting. The community is very vibrant. Libraries coming after libraries, and lots of cool things are happening now. We've got React use form, which is much more efficient way of forming, and it's at a very fast-paced development. The React concurrent algorithm, which I told you, the Fiber, also paves the way for concurrency and lots of cool features, which I can't wait to be released in React 18. It's currently unstable, but I played around with it and it looks pretty cool. And both React and React Native will get the advantage of that. React Native gets to a near native performance, of course, nowhere close to native performance. So rather than using HTML or platform-specific UI components, React Native allows developers just to write a component. It's highly compositional. You can have adjacent siblings. They call it siblings components, parent-children components. You can have them as a higher-order components. It's very, very compositional. As an architect, you will enjoy playing around with it and architect your application the way you want to. One of the biggest disadvantages of React is the sort of start time. So the bundle size is quite huge, which is affecting the performance, and it takes a little bit longer for the apps to load. That is the biggest thing. The React team developed this new technology, Hermes, if I'm not mispronouncing it, to try to alleviate this problem, but that problem still exists, and performance is still the issue. And I'll give you a little bit of explanation at the end of this lecture, at the end of this presentation, on what I think about React Native, and I will compare it. So I've got another 15 minutes. Let me go a little bit quicker. Titanium, This is also another dinosaur technology. It's pretty old, 2018, and you may not believe it, despite the fact that this project was kind of released as an open source product by Appcelerator in 2018. It is a native cross-platform development tool. 2008. Sorry, I got one number wrong, so I'm going to repeat myself. Titanium has been released in 2008 by a company called Appcelerator as an open source SDK. And in 2008, they've released this as a native cross-platform tool. So these people were way ahead, which is very interesting. So they've reached a very good level of maturity. They have a large support ecosystem. I mean, like, it's starting to go obsolete, but still lots of people are there. There is a dedicated Stack Overflow board and a chat system available to paying customers who are using Titanium. One of the advantages of Titanium is that it's a really easy to deploy thing. The speed of deployment is very good. It has a good pedigree, as I explained, and it comes with an IDE called Appcelerator Studio. And Appcelerator Studio is an IDE built for Titanium Appcelerator, which will support you a lot in development. Titanium provides access to native APIs through a product called Hyperloop. And Hyperloop was their genius. Hyperloop allowed developers to access native APIs written in Objective-C, Swift, and Java using JavaScript. And you could basically sort of access those APIs with JavaScript only. And it was pretty cool at the time. Titanium also was, I think, one of the first, if not the first, JavaScript solution that used the Alloy MVC, which was their architecture. And yeah, pretty much cool. I personally didn't have experience with Titanium Appcelerator, but when I researched about it and I saw the code and how it works, it was like, wow, that's so good for the time it was developed. So I was a little bit shocked. But there are weird things about it as well. First of all, XML views. Oh, Jesus, who want to work with XML, honestly? You will have to configure things using XML. And I personally, XML is the least of my favorites. Another thing about Titanium, which I've never seen anywhere else, is that they had their own proprietary style sheets. Like they had their custom style sheets. They called it Titanium style sheets. And they kind of look like CSS, but they really aren't. So it looks like a JSON-like syntax to declare styles. Yeah, but it varies from CSS. So you're going to have a little bit of learning curve. I'm sure you don't want to pick this in 2020. This is just for educational purposes. But yeah, these people had some great ideas, and they were really in the very early 2008. And now our next framework is Xamarin. So C# guys and people coming from Microsoft and .NET know Xamarin very well. Xamarin apps are compatible in performance to native apps written in Java, Objective-C, or Swift. Comparable in some cases, not all cases. They provide native UI components either through Xamarin Forms or through native UI development, ensuring that Xamarin apps look like every other native app. They also work with common device functionality across platforms via plugins and specific APIs to eliminate compatibility issues. One of the things that is interesting about Xamarin is that it supports linking with native libraries, allowing for better customization and native level functionality with little overhead. The Xamarin SDK is open source, so you can get it. And because it's integrated with Visual Studio and Microsoft supports it, it is assured that it's not going anywhere. Like Microsoft will, he's your guy, he will back it up, not going anywhere. And you're not going to feel like the Cordova kind of a thing. I mean, like, don't get me wrong, Cordova has been developed by Apache Foundation, which is one of the most creative technology companies. But yeah, Xamarin is, I would say, would be there. There are more chances that it won't go away. And as you guys know, Microsoft has virtually abandoned the mobile OS segment, and it has focused on Xamarin within the last years to try to make it better and better. Because Xamarin uses C# and .NET, so it already has a great community. People already have a skill for it, and people can just jump on it. If you know C#, just jump on it. And .NET Core is getting so huge these days, one of the most loved frameworks. So that means Xamarin will come up as well, because if you're a C# developer, there are chances that you don't want to learn React from scratch, or Dart and Flutter. So yeah, this is going to be an interesting thing in the near future as well. For disadvantage, learning curve, if you want to pick up C# and get into the Microsoft stack. And also, apps written with Xamarin, and specifically those written for Android, are notoriously larger than their native counterparts. This is something about Xamarin that is a little bit of a letdown. And I've researched about it, and I realized that the result of this is the result of a support libraries needed to translate C# calls to native calls. So translating those C# calls to native calls results in very huge apps comparing to the native ones. Our next friend is NativeScript. NativeScript is very new. It's definitely a new kid around the block. I personally found out about NativeScript because I was really into Svelte.js, and then I was like, I watched a video on YouTube about Svelte, and I was like, wow, this is so cool. This looks so performant, and you don't need all the virtual DOM and all the processing stuff, and it's just like a, they call it compiler as a framework, yeah. So in that way, it's very, very cool. And I was looking for a NativeScript, I was looking for a Svelte solution. Then I came to NativeScript, and the people in Vue community, Angular, and the Svelte community, if they wanted to go cross-platform, NativeScript is their friend, and even JavaScript. Okay, I have 7 minutes, so I'm going to go a little bit quicker. Advantages is that it will give you near native performance. I've heard on the grapevine that Airbnb has got NativeScript. Don't quote me on this. That's what I heard. But NativeScript shows a lot of potential because you got Vue developers behind it. I mean, like Vue community behind it, Svelte community, and Angular as well. It's open source, and it also has a good performance, near native performance. I think, it's a typo actually. Both of them are advantages. The disadvantage is that it's a little bit immature. So it's been around since 2015, if I'm not mistaken. So yeah, it's not there yet. So it has a small community. That's the only disadvantage that I know. If you guys know more than that, please come back to me and illuminate me. And lastly, our friend Flutter, the hype of 2018. Everyone's around it now. People ask me these days, should I go Flutter? Should I go React Native? And blah, blah, blah. And I'm going to tell you what I think about Flutter after I give you an objective explanation of what it is. So Flutter has been developed by Google in 2018. It runs on Dart and Flutter. What I love about it is the widget catalog, which makes development much easier. You just get those widgets and put them in your code, and there you go. It has a near native performance. And the disadvantage is that, if you want to compare the learning curve of all the other things that I tell you, I think Flutter has pretty steep learning curve because Dart looks like Java and JavaScript had a sexual intercourse, and the result was Dart. with the fact that Java was the father, because you have classes and all that kind of things, object-oriented stuff. So yeah, it's a learning curve. And another problem is that performance can be an issue for older devices. So that's another thing that I've encountered, and I've realized that lots of Android devices that are running on old APIs will really suffer if the app is written in Flutter. Now, getting all that together, and also with my development experience, what I want to tell you is my absolutely subjective point of view on which way you should go. Let me tell you something for brief. If you have a very complicated application, let us say stock trading application, or something that involves heavily with animations and UI interactions, there are chances that cross-platform technologies are not the smartest solutions. Based on the statistics and surveys out there, 99% of app usage goes only to top 10 apps. So everything we develop is in the territory of that 1%, even less than 1%. So if you want to go big, you want to change the world with your app, go big. Go big or go home. Go native if you have a app that requires lots of functionality. Stock trading app is one good example of that. If you're going for something simpler, for example, you want to develop a booking app, and the booking app doesn't do something fancy, it's just a very simple UI that allows you to kind of just book things and go through it, then I think hybrid solutions are not bad. If you want to go very quickly and you have lots of web developers available, and native solutions are even better. There is a big kind of discussion out there on React Native and Flutter. From my point of view, they're pretty much very close to each other. Flutter has been developed in 2018, which means it's a very newer technology. But the way I look at it, it is not really much different when it comes to the overall underlying architecture. I don't have the time to describe all of that for you guys, but I'm just going to finish my last slide because I think this is the end of my presentation. There are things that I've listed based on my experience and research that you should not do. I mean, like when you don't want to go cross-platform. Sorry, I will rephrase it. There are scenarios in which you don't want to go cross-platform, and I've created a good list of them. Here's a list. If you're targeting a specific platform, of course, you don't want to go cross-platform. If you're using a low-level device hardware, such as the camera, GPS, or accelerometer, you don't want to go cross-platform. And if your app relies on core OS libraries, such as the graphics system, you don't want to go cross-platform as well. And if your app needs to be really fast and responsive, you don't want to go cross-platform. So in a nutshell, that's all I had to say. I just want to seize these 2 minutes and tell you what was my research on React Native and Flutter. First of all, what I do first is that I go check the libraries and see how many issues are open. I saw that there were lots of issues open on Flutter. I found 8,000 open issues. One of the other things that I didn't like about Flutter is the material and the way it doesn't allow you to, for example, check an input size. So to be whatever you want it to be, you can't do it because they have policies for it. Another thing is that API 21 was one of the biggest problems. If your Android device is running on API 21, Flutter is going to be very slow for you, and React Native is not that slow, honestly. I found a quite number of benchmarks online. There are not many, but in those, Flutter looked a little bit faster than React Native when it comes to CPU utilization. So I think Flutter team has done a great job in writing a bridge that will convert not a very resource hungry, CPU hungry kind of a native code. I mean, like, lots of people are Google lovers and are a little bit biased on Flutter, but you will have to know that Google can produce trash as well. I'm not saying Flutter is trash, but I'm definitely saying Material has given us hard time in our company, and we had lots of troubles with materials, and that's something we'll try to avoid in the long run if we don't want to come back to those problems again. So yeah, I think that's all I had to say. I had way more to say, but we don't have time here. So yeah, thanks for listening.
Yeah, thanks a lot. It was pretty exciting, pretty interesting, because we had those questions during the course of our conference today. How about Xamarin, and how about this? How about that? So basically, thank you for helping us to do the job, to clarify certain parts, and just give an overview of and your opinion as a developer, as a senior developer, on what actually the state of or the progress of the apps, whether they are dying or they emerging and stuff like this. And we'll talk to you at the Q&A session, and I believe we will have a couple more questions regarding other frameworks except React Native and Flutter. And thank you.
Yeah, sure.
Thank you for now. Yeah, and we'll talk to you like in 40 minutes.
Sure. I will see you later.
Thank you.